All right, welcome to part 4 of the Study With Me series on Kafka Streams DSL. And today I'm coming to you from the basement here because we've got the in-laws filling up the house upstairs and I'm on carrying the baby duty at the moment. So thanks for doing a Study With Me session again, where I read out loud documentation and process it out loud by talking about it and commenting and questioning it. And if you have comments and questions as we go through the documentation, leave it below. So if we look at the table of contents here, we left off last time in the stateless transformations at flat map values. So we'll continue with Foreach this time. And I apologize if there are some utilities making background noise. I hope the Zoom noise cancellation handles a lot of that. I'll try to speak up to make it easier to cancel that out. Anyway, Foreach, K-stream to void, K-stream to void, K-table to void. Okay, that might be a typo that they repeat that. But anyway, I guess you can use Foreach both in streams and tables is my takeaway there. Terminal operation performs a stateless action on each record. Okay, and terminal, I guess, means that's the last thing you do. It void, it just goes on into the nothingness, into the ether. Okay. You would use Foreach to cause side effects based on the input data, similar to peak, and then stop further processing of the input data, unlike peak, which is not a terminal operation. Okay, that's interesting. They call it a side effect to have like a print. Yeah, I guess you would usually use print in the Foreach. So I guess that's called a side effect rather than further processing. Whereas peak is not a terminal operation. Note on processing guarantees. Any side effects of an action, such as writing to external systems, are not trackable by Kafka, which means they will typically not benefit from Kafka's processing guarantees. Okay, I guess because we're just maybe printing the messages to an external system and that's it, that's the end of processing, we're not going to get any processing guarantees. Okay, and now let's look at this code example of Foreach. So we've got K-streams, takes a string and a long, stream equals whatever you want, and then print the contents of the K-stream to the local console. Java 8 plus example, using lambda expressions, stream.foreach key value, system out, print line, key plus, and arrow value. System.out.println key. So this is basically just prettyifying the output. And then we have another code example here in Java 7. And as always, Java 7 is a lot more verbose than its successor Java 8. So in Java 7, we write the same thing, stream.foreach, but then we need to have this Foreach action, a new Foreach action, which takes a string and a long, and at override public void apply string key long value system.out.println, and that's the same thing, just prettyifying the output. Okay, pretty straightforward. I guess this is pretty good for debugging and so forth, to just print the output and not do anything after that. Moving on, GroupByKey, K-stream to K-grouped stream. Groups the records by the existing key details. We can skip the details for now. Grouping is a prerequisite for aggregating a stream or a table and ensures that data is properly partitioned, keyed for subsequent operations. Oh, okay, so it's a prerequisite. So before you aggregate a stream or a table, you want to group it. So you take a K stream and you put it into a K grouped stream. That way the keying is properly configured, properly partitioned for subsequent operations. So properly partitioning, the synonym there is properly keyed. When to set explicit SERDES. Variants of GroupByKey exist to override the configured default SERDES of your application, which you must do if the key and or value types of the resulting K-grouped stream do not match the configured default SERDES. This was a note in a previous thing as well. Yeah, here we go. So it mentioned this in the section on creating source streams from Kafka. It continued mentioning the importance of specifying the SERDES explicitly. And now this is the first function where it calls that out again, is the GroupByKey. And you can click on the link to go back and watch that study with me video on creating source streams from Kafka in case you missed it. Okay, going back to the GroupByKey. It also has a note on grouping versus windowing. A related operation to grouping is windowing, which lets you control how to subgroup the grouped records of the same key into so-called windows for stateful operations such as windowed aggregations or window joins. Okay. So it seems like it's a versus, right? You can either do grouping or windows, and it seems like windowed is a little more nuanced because it doesn't just let you group, it lets you subgroup. So it lets you partition the records by key, which is a synonym for keying, but then it lets you go one step further and lets you subgroup by things such as session or epoch time and other things that you can do with windowing. And another bolded comment here is that GroupBy causes data repartitioning if and only if the stream was marked for repartitioning. Okay, so how do you mark a stream for repartitioning? And why would it not repartition the string if the whole point of GroupByKey is to kind of repartition the data by key? Okay, so GroupByKey is preferable to GroupBy because it repartitions data only if the stream was already marked for repartitioning. However, GroupByKey does not allow you to modify the key or key type like GroupBy does. Okay, so GroupBy is more flexible because you can not only modify the key value, but you can also modify the key and the key type. However, GroupByKey has kind of a smart feature, I guess, of not repartitioning the data unless the stream was already marked for repartitioning. It seems like GroupBy indiscriminately just repartitions the data no matter what. So let's look at an example. K-stream byte array string stream equals. Group by the existing key using the application's configured default SERDES for keys and values. K-grouped stream byte array string grouped stream equals stream dot group by key. By the way, can someone leave in the comments, do I say byte array for that? Yeah, byte array. Okay, good. Again, coming from a JavaScript, not Java background, all these type declarations are different in Java. When the key and or value types do not match the configured default SERDES, we must explicitly specify SERDES. And here we have it, K grouped stream byte string grouped stream equals stream dot group by key serialized dot with SERDES dot byte array, and you provide the key here, SERDES dot string, the value here. Okay, so I'm looking for the function, and here we have it, group by key. That's the function we're talking about here, is a group by key. That's the one that's preferable to group by. And is there anything in here that tells us if the stream was already marked for repartitioning? We have the input stream here. Doesn't say anything about marked for repartitioning. So I'm going to just look that up. How to mark a stream for repartitioning in Kafka. Okay. Note, map marks the stream that it requires repartitioning, and GroupByKey.count will create the topic for repartitioning. With this regard, repartitioning is lazy. That is, it is only done if required. If there is no GroupByKey.count, there would be no repartitioning introduced. Okay. So we can chain these functions together. Stream.map, the map marks the stream for repartitioning, and Kafka Streams automatically inserts the through step and thus computes the correct result. So I'm guessing we don't need this in current versions of Kafka, but if we're using Kafka Streams 10, you will need to create the repartition topic manually with the desired number of partitions, and you will need to add the call to through to your code too, but in .11 and up you don't. And then GroupByKey groups it, and then groups it for aggregation. And the GroupByKey is the step that repartitions it because it was marked for repartitioning via map. Awesome. That's a great comment. I'd give it a like, but I'm currently not signed in because I'm on demo. account here for the demo or the study with me video. Okay, so that explains a little bit more about marking for repartitioning. I guess it depends on what you did with the stream before the GroupByKey step. It's not like a flag or something that you add as a parameter. It's literally what functions did you apply to the stream beforehand. Okay, moving on to the next function here, GroupBy, KStream to a KGrouped stream, and KTable to a KGrouped table. All right, and it says here, GroupBy groups the records by a new key, which may be of a different key type. Okay, so when you say GroupBy, it definitely means you're going to be grouping by a new key, whereas GroupByKey doesn't necessarily need a new key, or it definitely doesn't use a new key. GroupByKey always uses existing keys, whereas a GroupBy always uses a new key. I guess you can remember that because GroupBy what? GroupBy, you got to provide it. It's a new key. Whereas this one, GroupByKey, it just means use the existing one. Don't have to specify which key. Just use the existing. Whereas here, GroupBy, and then you got to provide it. So it groups the records by a new key, which may be of a different key type. When grouping a table, you may also specify a new value and value type. GroupBy is a shorthand for select key.GroupByKey. Ooh, that's cool. That's very cool. Okay, so select key can change the key and the key type, I guess, for each record, and then GroupByKey can group by the existing keys that are the outcome of this, whereas GroupBy can do both the grouping and the changing of keys. That's pretty cool. KStream details and KTable details. We will skip that for now. This documentation is long enough. Grouping is a prerequisite for aggregating a stream or a table and ensures that data is properly partitioned, keyed for subsequent operations. Okay, that's the same as the previous section, GroupByKey. So is this, and so is this, and this is different. GroupBy always causes data repartitioning. Yes. If possible, use GroupByKey instead, which will repartition data only if required. I guess the reason GroupBy always causes repartitioning is we're providing new keys. Keys are the basis for partitioning. So if you change the key, you change the partitioning. You repartition. Makes sense. Okay, KStream. Okay, so we're declaring the values we're initializing a stream here, and we're initializing a table here. And we've got it says K Java 8 plus examples, and then these are Java 7 examples. And as always, the Java 8 examples are shorter because they use lambda expressions. Okay, so in the first example, where we want to group the stream by a new key and key type, we have K-grouped stream. We create a grouped stream by taking the input stream, applying the GroupBy method, and we take the key and value as input, and we output the same value, but then we do something with the key because it says value without any modifications here, and then comma, serialized with 30 is string, and key, note type was modified. Oh, okay, type was modified. Oh yeah, okay, because the key used to be a byte array, and now it's a string. I guess that's how I'm reading that. Leave a comment below if I'm wrong. Okay, group the table by a new key and key type, and also modify the value and value type. Oh, okay, so we can also modify the value and value type. We don't only have to mess with the key when we use GroupBy. So in this example, we're using a table, but we could also do this with a stream, the modification of values in addition to keys, but here we're doing it with a table. So table.GroupBy, input key and value. And yeah, this time, see here we had the value unmodified, just value. This time we're doing something with the value. We're creating a key value pair. The value is becoming a key value pair itself. It's like nested. Value.length. Okay, so the value here is an integer. What happens in Java if you call the length method on a integer? With JavaScript, you can only do it on a string. That's what I thought. What about Java length? I don't think so. So I'm probably misreading this here. Makes me want to learn Java better. Anyway, K-grouped table takes a string in an integer. Table GroupBy. Yeah, how do you take the length of a value that's an integer? I don't know if that is a typo in the code example or if I'm just reading that wrong. leave a comment below if you know what is going on here with what seems to be an integer for the value and length. Or maybe I can look at the documentation for k grouped table and initializing one of those. Yeah, no, it says key and then the value, as you would expect. So it really seems like the value is an integer, and I don't know why you would call the length method in Java on an integer. Comment below if you know. Okay, and then you're also, as in the previous example, modifying the key and key type. So it used to be a string, and now it's a string. Again, confusing. And integer. I'm guessing what they meant to do here was flip it around, where it's string and integer, and then it's integer and string. But I think, key is string here, key is string here, integers, values, integer here, and values, integer here. So it's not really type modification. Might be a typo. Okay, Java 7 examples. Okay, so I'm going to skip this because it is the same thing, but just in an older syntax of Java 7, more verbose. And moving on to the next stateless transformation map that takes in a k stream and outputs a k stream. It takes one record and produces one record, one-to-one. You can modify the record key and value, including their types. So map is very broad. You can change everything about the record, but it's always one-to-one. Whereas with branching, you can create 0, 1, or more streams. And with flat map, you can create 0, 1, or more records. Let's just double check that. Yeah, so branch splits based on the supplied predicates into one or more k-stream instances. Okay, I said 0, 1, or more. I think that's kind of right, because if no predicate matches anything, the records are dropped. So what if you have no records matching? That's like 0 streams, right? Okay. And flat map produces 0, 1, or more records. So the difference here is branch 0, 1, or more streams, flat map 0, 1, or more records, and then map 1-to-1. It always produces one record for one input. So I think those three things are helpful. Those three differences are useful to remember. All right, so map marks the stream for data repartitioning. I wonder why it marks the stream for data repartitioning, because what if you're only changing the values? If you're only changing the values, you might as well use map values, because that indeed does not repartition the data. I guess since map values exists, it assumes that if you're only changing the value, you're going to use map values. Map kind of assumes you're going to be also modifying the key, and therefore it just indiscriminately, whatever you do with map, it will mark the entire stream for data repartitioning. Okay, and that answers our earlier question in bold and official documentation, the thing we were reading on Stack Overflow before, which is that map marks the stream. How do you mark a stream for data repartitioning? By using map. Maybe there are other ways that we'll come across later, but map is one of the ways to mark the stream for data repartitioning. Okay, good to know. So if possible, use map values instead, which will not cause data repartitioning. And then we have examples here, and I'll only go over the Java 8+ because it's more concise and fun to read. And note how we change the key and the key type, similar to select key, as well as the value and the value type, right? Because with select key, we can change the key and the key type, but we're also changing the value and the value type, whereas select key only deals with the key. So k-stream takes in a string and an integer. Okay, so we're creating a stream called transformed. We're taking the input stream called stream. We're applying the method map, and we're taking the input key and value, and we're outputting a key value pair. And this is what the new key and value will be. I guess we're just ignoring the key basically in the output stream and outputting the value to lowercase as the new key. So like if you had the key be like a list of states, let's say, and then some of the keys were like Alaska with a capital A, some of them were with a lower a. Now all of them will have, oh no, but this is values. So we're dropping the keys and we're only taking the values. Okay, yeah, let's stick with the example where the input stream had a byte array as the key and a string. Okay, so just as a little sanity check here, if we have topic with string as the key and byte array as the value, and we were to just print that record value, the system out would look something like this for that byte array. So with a byte array, you need a serializer to make sense out of that, or a deserializer, I guess. So if we go back to the example here, we were kind of dropping that byte array that would need to be deserialized and just taking the string. So I guess that byte array could be auto-generated by Kafka for the incoming messages. So you've just got messages coming in, and then you're going to transform that message. So let's say it is like a message ID, and then the message contents, which could be like, I don't know, what's a good example? Player one. Oh. Okay, I just remembered a very common use case for Kafka are logs. Okay, so let's say you have the value of the message be a log entry from an Apache HTTP server, and the key of the message coming in is a byte array. So you kind of drop the key and you make the new key be this entire message, lowercase here, value to lowercase, and then the value, the new value of the transform stream is the length of this, it'd be 85. So you get this message in lowercase as the key and 85 as the value if this mapping were applied to that Apache web server log. Okay. Cool. And then the same thing in Java 7. Okay, I think we can stop here for this video, and we'll pick up next time with the stateless transformation of map values only. And after that, we only have a few more stateless transformations before getting into stateful. We've got peek, print, select key, and table to stream coming up soon. So please subscribe so you can get the next video of studying this Kafka Streams DSL official documentation, and please comment below if I got something wrong, or if you have a tip on how to remember some of this better, or you have a good example of how to implement something like this, or a good mental model that helps you, please comment below. Please like if it helped you too. And in the description below, there's my Medium blog link where you can subscribe to my blog posts, and my Twitter handle and my LinkedIn profile, so you can follow me there for the latest content as well. Thanks. Until next time.